Hello and welcome to Understanding Maps. Today's lesson is, what are the types of maps? So in this lesson, we're going to learn two things. One, how can a map help determine a location? And two, why are there different map projections for representing Earth's surface? So let's start with some key vocabulary. The first word is map view. Now, a map view is a view drawn as if you were looking down upon the Earth's surface. We call that a map view. So it's like you're up in the sky looking down at the Earth. That's the typical type of map we're used to seeing. But it's called map view. Profile view is a drawing that shows as if you were looking at it from the side, and it's usually about elevation, etc. So it's like a cross section and you're kind of looking at it from the side. So map view is from above, profile view is from the side. You also have a map legend. A map legend is kind of a key that we use to be able to read the map, because it's going to tell us about all the different things on the map. Where the roads, bridges, bus stops, rivers, etc. We use the legend to understand it. You also have map scale. Map scale is the relationship between a distance on the map and the distance on the ground. Because we can't have a map that's an actual size. That would be a really big map. All right? So we use map scale and say, for every centimeter equals 1 kilometer, something like that. And we call that map scale. You also have what's called longitude. Longitude is a distance in degrees east or west of the prime meridian, which is in England. So you have the prime meridian, and then you have other longitude that separates the Earth in degrees going around it from east to west. The other one is latitude. Latitude is the distance in degrees north and south of the equator. The equator is at 0 degrees, and then you have different degrees of latitude north and different degrees of latitude south of that equator, which is 0. You have time zone. Time zone is the areas of the Earth's surface that have specific times, because the time zone is where people use the same time. So, for example, the people in Thailand use one specific time, but if I was calling the people in Japan, they would be using a different time zone. So Thailand has a different time zone than Japan. But Thailand does have the same time zone as a lot of people in China. You also have what's called the international date line. Now that is a line of longitude 180 degrees east or west of the prime meridian. It basically goes right down the Pacific Ocean. And so, have you ever noticed, if you've ever traveled on a plane and you travel across the international date line, you may leave, let's say, Japan on a Monday at 8 a.m. and for some reason you arrive in California at 9 a.m. Monday. So it's almost like you lost no time. That's because you crossed over the international date line in the Pacific Ocean. So let's begin your lesson. Now, we always said a map is a model of the Earth, right? And most all maps are drawn with map view, looking down at it, looking down at the Earth's surface as a flat surface, similar to this one right here. Now, they also have another name for map view. They can call it plan view, but most everyone will just call it a map. And a profile view is showing a slice, like you're looking right through it, and it's usually about elevation. Now, maps have two features that help you read and understand them. One is called a map legend, right? And that'll kind of tell you what you're looking at, so you can understand what you're reading. And the other is called a map scale. And the map scale will help you to understand, even though, let's say you're looking at Beijing right here, right? And you're saying, well, what's the distance from Beijing to, let's say, Hong Kong? Now, you could measure that with a ruler, but that's not the actual distance. So a map scale will help you decide what that is. So again, here's a nice example of a map legend. You know, they're different for every map. It all depends. But you can see it has everything that you would need. This looks more like a map that you would use if you're traveling, because it has temples and bus stops and roads and bridges, etc., even places to eat. Now, modern builders typically use scale. Why? They use scale to make models, so they have a nice small one to work with. Now, you've seen this when they're building buildings. They have like a little scale model of a building, or if they're building a car, and you'll see them looking at it. So, you know, or on a computer, a 3D model. And they use it to scale rather than saying, you know, let's do actual size. Because imagine looking at a car model on a computer that's actual size. Now, you can always zoom in on it. Now, a map scale is the relationship between the distance on the map and the actual distance. Or in the example of the car, the scale is the ratio. So, this one, for example, this map, the scale or ratio is 1 centimeter equals 1 kilometer. All right. So every good map will give you a scale so you can judge distance from one place to the next. Now, long ago, when people were setting sail and going around the world, etc., they had to make kind of a grid system. A grid is something like this, right? So they could kind of figure out where they were at. So they made these imaginary lines, and they called them longitude and latitude. And they kind of laid this grid over the Earth's surface so they could figure out where they were at any place on the Earth. So, and they called these latitude and longitude. All right? And using those, we can pinpoint any decision or any location on Earth. Now, the half of this vertical that passes through a place called Greenwich, England, is known as the prime meridian. All right? The other half of the vertical circle is known as 180 degrees meridian. So you have one prime meridian, and then all the way on the other side of the Earth, you have the 180 degree meridian. So it kind of like is two different points on two different sides of the Earth that you could cut the Earth right down the middle. So again, you have the prime meridian that goes right here, and it is 0, right? So similar circles are drawn every degree east and west of the prime meridian. So then you have 20 degrees, 40 degrees, 60 degrees, all the way across these longitude, all the way to 180 degrees. Now we call these lines meridians, all right? Meridians. You have the prime meridian, which is 0, and then you have the other meridians, which are 20, 40, 60, 80, 90, 100, all the way up to 180. A location's longitude is the distance in degrees east or west of that prime meridian. All right? And this is also how we divide the world into the Western Hemisphere and the Eastern Hemisphere. Now the lines east and west are called, again, east longitude or west longitude. All right? So depending on which way you're going, you would call it east longitude or west longitude, all based on that prime meridian of 0. So lines east or west. West is negative, east is positive. But you wouldn't say negative 30 degrees. You would say 30 degrees longitude west, or 30 degrees longitude east, for example. They also drew horizontal lines from east to west. Now, the middle of the Earth, so again, vertical, horizontal, right? So the longitude is vertical. The latitude is horizontal. So you have the equator, which is 0, all right? That's the largest one going right through the center of the Earth. And it divides the Earth into the north hemisphere and the south hemisphere, northern and southern. The equator is right in the middle. They draw these degrees north and south of the equator, and they are referred to as lines of latitude. Now, the North Pole and the South Pole are 90 degrees north or 90 degrees south of the equator. All right? And that's the very top, the very tip. You have the North Pole or the South Pole. Now, a location's latitude is the distance in degrees north or south of the equator. And remember, it's up to 90 degrees north or 90 degrees south. So together, longitude and latitude are used to make any location. And you always see this in GPS. If you've ever had to enter in the number, it always has two sets of numbers. One number is longitude and the other number is latitude. And from using that, they can find the location anywhere on Earth. And you always see that when you're in your GPS system and it asks you to enter in the number. So let's look at a key concept check. What relationships do lines of longitude and lines of latitude have? What is their relationship? Well, together, their relationship is they are used to pinpoint a location on Earth. So you have to have both latitude and longitude. You can't just have one. You need them both to find a location on Earth. So, like we said, any location on Earth can be described by the intersection of the closest latitude and the closest longitude. But they're pretty far distant, right? So you have when you have the latitude and longitude, what you have is this big square right here. So that they're separated from. Now, what they do is they take that square, right? So I'm going to draw that square here. And then they divide it into 60 minutes, and each minute into 60 seconds. And that makes it much more detailed. So they take that and they divide it into minutes and seconds. Now, I can't draw the detail because you're talking about finding an exact location of where you are standing on this Earth. So you can imagine the detail of minutes and seconds right down to a specific place on Earth. So if I said, I want to find out where in Bangkok are you standing, for example, I can do that with latitude, longitude, and then taking the minutes and the seconds of latitude and longitude. So another key concept check. How do latitude and longitude describe a location on Earth? Well, it is the intersection of the closest line of latitude and the closest line of longitude. And then from there, we use the minutes and the seconds to find out the exact location. Let me do this. Sorry, my handwriting is pretty bad. So, then you use the minutes and the second to get more and more accurate as to the location on Earth. Now, time zones are because basically specific locations on Earth have a shared time, but it's not the same time everywhere on Earth. So we divided the Earth into different zones depending on where you are. And this is supposed to make travel and business easier for everyone. Because you can imagine, I'm here in, let's say, Thailand, and I want to call someone in New York City. right? All the way across the world. And so here I am, and it's 1 o'clock in the afternoon. I just came back from lunch. I said, you know, I'm going to call my business friend in New York City. But see, because the Earth is spinning, he's all the way over there, and it's not 1 o'clock in the afternoon, it's 1 a.m. in the morning, and he's probably sleeping. So by having these time zones, we can quickly find out, oh, what time is it in New York? And then you think, oh, I shouldn't call my friend right now. I should wait until he wakes up. Now, the width of a time zone is 15 degrees longitude. But sometimes what they do, because of politics, sometimes they don't follow 15 degrees, right? They're not a perfect 15 degrees like you see up here. Sometimes because of politics, they bend themselves. Because you don't want people, for example, here, if this went straight, you would have these poor people in Russia, right there, that literally could cross the street and time would change for them. So you just want to be careful. So sometimes some people have moved the boundaries based on politics. Now, the international date line is a line of longitude, right? And it's at 180 degrees longitude, east or west of the prime meridian, which is on the other side of the world, and the prime meridian is 0. Now, when you cross the date line from east to west, it is a day later. So if I'm coming from California and flying over to Japan, I will lose a day. Even though, let's say, I'm leaving California on Friday at 9 p.m., I'm actually leaving California at Saturday at 9 a.m. on the other side of the world. So you lose a day as you travel from east to west. Again, make sure you understand the international date line does not follow the exact 15 degrees that we talked about. For example, you see this strange little shape here. That is because there's a group of islands out in the Pacific, and they didn't want to be divided up. But, you know, their space very far apart, so they kind of manipulated the international date line so you wouldn't travel from one island to the next island, and it's Tuesday here, but it's Wednesday here. So they kind of, to help them out, they did this little redesigning of the international date line. Now, one way to transfer features from a globe, you know, a globe is round, just like the Earth, is to make a projection. And you have different types of map projection. All right? There are two types. They are called cylindrical, right? And conical. Cylindrical and conical. Now, understand that both of these maps, whether they are cylindrical or conical, they have distortion. That means they are not true pictures of the Earth. All right? There's no way to take a three-dimensional round sphere and turn it into an accurate flat map. There's always going to be a little bit of difference on the map that isn't quite accurate. So what are the advantages and disadvantages of cylindrical projections and conical projections? The advantages of both of these types of maps is you can make a flat map instead of carrying around a ball or a globe. The disadvantages are their distortions. Like, for example, if you ever look at a what they call a cylindrical map, and it's like they wrapped a piece of paper around the globe, right? This is your cylindrical map right here. So they took a piece of paper and wrapped it around the globe. Now what happens on this is you start looking at things towards the top, and they're looking a different size than what they really are. You know, so that's what we call about distortion. It's not accurate as to the size. Whereas like something in the middle, for example, may be very, very small, even though it is enormous. Like sometimes I see a map where Africa is the same size as America, and that's not true. Africa is a huge continent. So, but the distortion from making that cylindrical map makes it look smaller. So in summary, remember, finding locations on a map or globe can be done accurately simply by using longitude and latitude. And understand that different projections of a map offer different solutions, but also different distortions. They're not all true. All right, so this happens when you transfer 3D to 2D. There's going to be some change. That's your lesson on what are the types of maps, and we hope you enjoyed the lesson and hope to see you for the next lesson also. Thank you.